Then start next session.
Yes, sir. Start, sir.
Okay. Once again, good evening to all participants. I'm welcoming now our second session, Mr. P. Rajendran sir. He is going to talk about the global energy storage and conservation trends and outlook. He is having more than 33 years experience in various energy related companies. I think he is very good knowledge in energy and storage. Definitely we will enjoy his presentation. So I'm also eager to listen his presentation and speak. So I welcome you once again, sir, Mr. Rajendra sir. Please take over.
Sir, can you give me permission to share my slides?
Yes, I already given, sir. Already given.
So thank you, sir, for the nice introduction and global.
Yeah, please, sir. Once again, sir. Mr. Jab.
Very good evening to all. It gives me immense pleasure to welcome Mr. P. Rajendran, Chief Assist Officer, Ever Renew Energy Private Limited, Chennai. He has an experience of 33 years. He honed core competencies in service operations, business development, customer service, people management, planning, and administration. He has successfully managed after-sales business for leading companies in the power sector. He began his career as a boiler pre-commissioning engineer at Cedar Vessels Limited before undergoing marine apprenticeship training and serving as a marine engineer abroad merchant navy ships. Subsequently, he joined Versatile Corporation as a service engineer overseeing the maintenance of diesel power plants. During his tenure at Versatile, he transitioned into service sales and eventually managed the company's Sri Lanka business from Colombo. He later joined BGR Group, where he led the service operations to condenser tube cleaning systems. His career further advanced to Siemens Gamesa Renewable Power Limited, where he initially served as head of customer relationship management. Over time, he rose to become the CEO of the company's service business, a role he held for 8 years. During this period, he drove customer-centric strategies, achieved consistent revenue growth, and enhanced customer satisfaction. Currently, he serves as a Chief Assist Officer at Ever Renew Energy Private Limited. In this role, he is dedicated to advancing India's transition to carbon neutrality by driving adoption of sustainable energy solutions and ensuring their efficient management throughout their complete life cycle. Sir, over to you, sir.
Thank you, sir. Thank you once again. Ladies and gentlemen, very good evening. Global energy storage and conservation, trends and outlook. It's a very, very needed and relevant topic right now. You will understand as I go through the presentation why it is, right? Energy is the lifeblood of modern civilization. Every home we light, every factory we power, every vehicle we move forward depends on how efficiently we harness and store energy. Having said that, today we stand at a crucial crossroads. One side, the demand for energy is skyrocketing. The global demand for energy is skyrocketing. Why? Because it is fueled by population rise, rapid urbanization, and industrial growth. On the other side, the climate change is accelerating. So we are pushed to do something, right? We have to act. We can't keep quiet. We have to act. Why? Because climate change threatens our survival. It is an existential issue. So we collectively we need to act and see how we can mitigate the challenges posed by the climate change. So in this context, right, this topic is very relevant, and this is going to present a lot of opportunities, both in terms of work, jobs, as well as research. So as we said, why this topic matters most, right? We talked about global energy demand, we talk about climate change and sustainability goals. The question before us is not whether we need energy. So we need energy. As we advance, right, as the world advances, energy is needed. The question is not whether we need energy, but how we generate, store, and manage is the key. And that is very important to have a very sustainable future. This is where energy storage and conservation acts as a game changer. This is emerging as a game changer. I'm very happy that about 150 people are here, and I'm sure, right, when I talk from an industry perspective, it might trigger some ideas from you, and many of you definitely will find ways to contribute. This is not only going to help our families, our children, but the entire globe. So let us start about the growing global energy demand. So I'll just give you a key statistics to understand, so that you understand what is the magnitude of the opportunities which is available in this field, and what are the risks and challenges we are going to face. So the global energy demand, according to the International Energy Agency, our global energy demand is going to rise 50%, right, from the current levels. Today's baseline, if you see, it is going to rise 50% by 2050. Again, as I said, it is mainly because of the population growth, urbanization, and industrial expansion. And the other main trigger for energy rise or energy demand is going to be the transition to electric vehicles. Maybe 10 years from now, or 15 years from now, or even before, right? Most of the diesel and petrol engines will get converted to electric. So there is going to be a heavy requirement for electricity to power the electrical vehicles, to charge the EVs. And AI-driven computing, data centers, big-scale data centers, these are all very, very energy-intensive applications. And rising demand from developing countries. So countries like India, China, Indonesia, Brazil, they are all going to experience exponential energy demand growth as they industrialize and urbanize. So if you take India, right, India is set to become the third largest energy consumer by 2030. So it's just a question of time. By 2030, we will be consuming at least 8 to 9% of the total energy produced in this world. And though we are adding a sizable renewable energy capacity every year, maybe we are adding somewhere between 40 gigawatts to 50 gigawatts every year, but still there is a problem with the shortage of electricity, mainly because the challenges posed by the intermittency of the renewable energy nature. So why this problem? We all know that fossil fuels reserves are finite. Oil is going to end, maybe coal in another 100 years. So renewable energy is the solution, right? It is going to be is substituting the fossil fuels. It's already started substituting fossil fuels. That is one of the biggest challenge we have. Because of the use of the renewable energy, the grid instability, because of the intermittency, as I said, unlike the nuclear power plants or coal power plants, we don't get a consistent supply of electricity from renewable energy sources. So intermittency is there, and that is causing an instability in the grid. This is a challenge which we need to overcome. And rising cost, the oil prices are going up. It's not in the control. It's always fluctuating. But in case if you take renewable energy today, even the companies I work, we always give a flat electricity rate for 20 years. That is for the life cycle of the product. We always give a flat electricity rate to the customers. So that is the biggest advantage of renewable energy, which will keep your cost down. So what is it? Again, to overcome these challenges, energy storage is going to help in a big way, because it will balance the supply and demand, while conservation is going to reduce the waste. Either we have to generate more, or we have to consume electricity efficiently. So storage and conservation is going to play a big role in coming days. So next we talked about climate change. So climate change, everyone is aware, and very soon, right? Every individual has to act to do something to mitigate the challenges which is posed by the climate change. So this is an abstract. This is a very, very interesting slide. This is an abstract from the World Energy Report 2024, published by International Energy Agency. It is showing three scenarios. One is called the steps. That is a stated policy scenario. I'll tell what is that. And other is APS. APS is announced pledges scenario. And third is net zero emission scenario. So they are just given three scenarios. And then they have shown how much could be the carbon dioxide emissions. They have given the figures in gigatons, GT. What is gigaton? Gigaton is a gigaton of carbon dioxide is a unit of measurement that represents 1 billion tons of carbon dioxide. So it's approximately 1 billion tons of carbon dioxide. That is the measure they are given here. So if you see all the three cases, they are saying that the emissions are going to peaks in the year 2030, around 2030. And then subsequently, the emissions will fall. So that is the projections which has been given here. And in the first step, steps. So what is steps? Steps is a stated policy scenario. So what is stated policy scenario? Stated policy scenario is it provides a more granular sector by sector evaluation. It will take transportation sector, it will take a construction sector, it will take a industrial sector. So sector by sector, it will evaluate the policies that have been put in place to reach the stated goals and other energy related objectives. So every sector has a target, and they have actually analyzed those policies and targets, and then they have given a projection. This is a very high number because 2.5% temperature rise, this world will collapse, right? We are not going to be there if the temperature is going to rise 2.5. Though they are saying it by 2050 or something, but still, 2100, still it is a very risky proposition. And second is the announced pledges scenario. So what is announced pledges scenario? Announced pledges scenario assumes that all climate commitments made by governments and industries around the world will be met in full and on time. So every government has said, for example, India, if you take India, Indian government has declared that by 2070 we will achieve the net zero target. Likewise, most of the European countries have said that they will achieve their emission targets by 2050. So they have just taken the commitments given by the various governments in the world and the industries, and then they have come with a number which says it will be a 38 gigatons by 2023 and 32 by 2030, and then it reduces in 2040 and 50. And the last is the net zero emission. What is the net zero emission scenario? It means that cutting all carbon emissions to a very small amount, so that whatever the residual is left, it is captured using the carbon capture technology and durably stored or converted into other fuels by nature or other CO2 removal process, leaving zero carbon dioxide in the atmosphere. That is the very optimistic scenario which the countries have set. This was declared in the Paris Agreement, the very famous Paris Agreement. By 2050, the global standard should reach the net zero emission scenario. So with this, if you see, by 2023, it's about 38 gigatons of carbon dioxide. That will reduce to 25 gigatons by 2040 and 6 gigatons by 2050. So this is a very safe. If we are achieving this, the target of keeping the global temperature rise below 1.5 degrees centigrade is very much possible. And that is the best scenario, or the best gift which we can give to the generations which are going to come. What is the impact of climate change? Today, if you actually see 80% of the global carbon dioxide emissions come from burning the fossil fuels for energy. Rising temperature, extreme weather events, melting ice caps are direct consequences of carbon emissions. We are seeing very erratic temperature changes, climate changes, all because, and it is expected to go worse, right? As the emissions are going to peak in 2030, I think we can expect more of these disturbances. And as I said in the earlier slide, the global sustainability goals and agreement, the Paris Agreement, the targets net zero emissions by 2050. Then the United Nations Sustainable Development Goals, SDG 7, it ensures affordable and reliable and sustainable energy for all. Corporate net zero pledges. Many of the corporates around the world has committed to turn 100% green. For example, Microsoft has said by 2030, all its operation will be through green energy. Then Amazon is saying by 2040. Then Google says again by 2030. So even if we take our own Indian company like Tata by 2030, they have said that 25% reduction in absolute carbon emissions in all their units for scope 1 and scope 2. And 2045 net zero emissions across the globe. So anywhere where Tata is there, by 2045, they say they will be compliant to the net zero emission standards. So climate change is a problem. As I said, it is mainly because of burning more and more fossil fuels. Renewable is substituting, but intermittency of renewables is an issue. Need for decarbonization, that is the main objective for the net zero. So energy sector should move from fossil to the cleaner sources of energy, fuel. And still, we need to countries, the developing countries like India, China, Indonesia need more and more power. It will be very difficult for them to convert all the energy needs into green. So that's why India said by 2070, 2070 we will achieve the net zero targets. When the most of the European countries are saying they will achieve the net zero targets by 2050. Still, 770 million people in the world, they lack electricity, mostly in the developing regions. Solution is energy storage that allows a large-scale adoption of renewables. Energy conservation reduces the overall consumption and cutting emissions. So if by this time, I'm sure you would have understood what is the importance of energy storage and energy conservation. And by default, right, whether we like it or not like it, each and every one of us will be forced to conserve energy, and the storage will be a much needed thing as we move forward. Maybe it will be people are talking about microgrids. Even every apartment they will ask us to produce their own power by putting solar, having batteries or storage systems. So that is going to be the future. So as I said, energy storage is a key enabler. So we discussed this slide much earlier. Building for bridging the supply demand gaps, storage is required to improve the grid stability, because more and more renewable energy getting integrated to the grid, there is a lot of instability. So we need a storage which can act as a buffer and give stabilize the grid. Electrification of transport again needs a widespread adoption of EVs, and there is no point in charging the electrical vehicle with the energy generated from the fossil fuel, because it defeats the very purpose of using the electric EVs. So the EVs have to be charged by renewable energy source, and if we are going to use a renewable energy source, and again storage is going to play a very important role. And conservation, as we said, efficiency in industries and home. It is actually going to reduce the energy generation levels and lower the cost. Smart grids and demand response balances power consumption in real time. And behavioral changes, simple measures like using energy efficient appliances, reducing wastage, contribute to this cost. So what is going to be the key outcome of this session? As I said, I'm very happy that 150 people are here. By this end of this session, the faculty members or who are there as an audience today will have an understanding of the latest energy storage technologies, learn about the basic conservation strategies and policies, and explore future trends, including career and research opportunities in this domain. So that is the objective. My main objective is to give you an outlook what opportunities are present in this field, so that you being in the academic field, it your contribution is much needed for the world, because you're the people who actually do the research and integrate right whatever we learn and whatever we do. So in that sense, I'm very happy. Again, I thank everyone, the organizers, for giving me this opportunity to speak to you. So this is again about the power projections. In 2023, the global primary energy consumption reached approximately 620 exajoules, marking 2% increase from the previous year. So, what is an exajoule? Exajoule is a very, very large amount of energy. To give you a feel, one exajoule is equal to about 277.8 terawatt hour. So what is 1 terawatt hour is 10 lakh megawatt hour. So that is the scale of energy which we are talking. 620 exajoules is the global primary, global primary energy consumption in 2023. And as I already said, this number is going to increase by 50% by 2050. And top energy consuming regions, as I said before, it's China, United States, and India. China consumes about 26% of the total energy the world produces. United States 16, India is catching up now 7, and by 2050, I think it should be in the range of 15, 16. Developing economies are experiencing faster energy demand growth compared to developed nations. So here is the challenge. World needs more energy, and it has to be from the cleaner energy sources. Integrating the cleaner energy sources is a challenge, and that provides a lot of opportunities for research and career development. What are the future projections? As I already said this, we'll move to the next slide. So this is the pictorial representations of the global energy demand, consumption, other things that is presently it's about 620 to 650 exajoules. And if you actually see the fossil fuel trends, right, the red line at the top is the fossil fuel. The fossil fuel is decreasing, though it is dominating. Still, 80% of the world's energy needs is coming from the fossil fuels. Renewable is picking up slowly, it's picking up, and other sources are coming down. So when I say other sources, it's mostly the nuclear installations around the world is coming down. Renewable sources, primarily wind and solar, is picking up in a large extent, and the fossil fuel based power plants, power generation is coming down. So this is the global trend, and this is the future projection. By 2040, whatever we are saying, 620 exajoule will touch about 700, approximately 700 exajoules, and the fossil fuels domination will continue to fall. By 2040, if you actually see, still we are not gotten rid of the fossil fuels. Fossil fuel is still there, but the renewable installations are catching up, and other sources of energy is continuously declining. And this is just to give you a mix, giving the three scenarios. How does it stand? The steps, the APS, and the net zero emission category. So net zero emission category, if you actually see, it's clearly visible. At least 90% of the energy source is going to come from the clean energy. Today, most of the companies are moving towards 100% renewable energy. Some countries, at least 5 or 6 countries in the world, has already achieved the 100% electrical green energy target, right? Because these countries are very small and they're able to manage their consumption only with the green energy sources. Most of the European countries are moving towards 70-80% energy usage from the green energy sources. India is also moving. India, if you actually know, the government has set a very huge renewable energy target. The government has set the 500 gigawatts of renewable energy by 2030. If you actually see all these years, right from the beginning to date, right today, our installed capacity is about 425 gigawatts for the India, roughly about 425 to 450. And by 2030, the government is saying only by renewable energy we will add 500 gigawatts. It's almost the same, right? 100% we are just replacing with renewable energy or green energy sources. So that is how the world is moving today. As I said, the fossil fuel dominance still it's account for 80%. Still, it's a very dominant force in the market, and mainly from coal, oil, and the natural gas. You can see the percentage there. 27% of the fossil fuel is from coal, 31 from oil, and 22 from natural gas. And renewable is catching up now. So 29% of the global electricity generation has come from renewable energy source. The main source, as I said, solar, hydro, and wind power. So solar is leading now, then wind power, and then hydro. Even if you take India, we have installed close to about 95 gigawatts of solar and 45 gigawatts of wind. So that's how it is. And hydro, so though there are limitations, hydro is also a very good and cheapest source of clean energy. So, as long as the grid is concerned, when large-scale integration of renewable energy happens in the grid, these are the problems. So, intermittency. If you actually see the solar peaks and wind peaks are different. Solar normally peaks in the daytime, right? Around 10 to 12 or 10 to 1 is the peak generation for the solar. Wind is, it depends on the location, but mostly what I've seen from experience is wind always peaks in the late evening. So that is how it has been. So intermittency also there. If there is a cloud movement, there will be a drop in the solar generation. And wind, it's not very consistent. It is very fluctuating. So the intermittency of power generation is the biggest problem in both. So storage is going to make a big difference in these two sectors. Stability risk, we already discussed this, and there is also challenge with respect to the peak load management, because with intermittency, it will be very difficult to manage peak loads with the renewable. So with forecasting, proper storage design, and the renewable installation, this peak load management can also be managed with the energy storage system. Again, this is also a next trend which we are seeing a lot of movement happening now. From a centralized power grids to decentralized microgrids. Traditionally, if you see the world, the power is given by fossil fuels. So the world powers all these years has been made by either coal or the oil base or natural gas base. These are all big power plants. If you see actually the coal power plant, their sizes will be very big, 1,000 megawatts, 2,000 megawatts, 3,000 megawatt. So there's always been an idea of centralization and this. Which we are seeing now, this model is not very efficient, right? There are a lot of transmission line losses because you have to take the power from the place of generation to the place of demand. So sometimes the place of demand can be kilometers and kilometers away from the place of generation. So naturally, it will result in high transmission loss. So the movement is from centralized power plants or centralized grid to the decentralized systems. Decentralized, the future of energy shifting towards a localized and distributed energy system. So what does this mean? The microgrids. Microgrids are very smaller, localized power networks that can function independently, and it can also connect or it can be independent from the main grid. So countries like California, Germany, they already have a lot of solar microgrids, community-based projects, and reducing the reliance of on the centralized systems. Microgrid has an advantage: either it can act independently, or whenever is required for balancing and other things, it can always drop off from the grid. So these are the benefits of decentralizing the grid. Your transmission losses reduced to a great extent. It enhances the grid resilience. It gives stability to the grid, so it's able to manage the peak loads. So this is one of the biggest thing. Integrates renewable energy more efficiently because of the size. The microgrids are small, and we can easily store and manage energy with the use of proper storage system. So integration of renewable energy to microgrids is very easy compared to integrating renewables with bigger grids. So this to just to give you an idea how the microgrids work. As I said, there is always a possibility to connect your microgrid to the utility grid whenever it's needed. Either if there is balancing of power is required or the power generated is not sufficient. So that flexibility is always there. Anyway, this is going to help to reduce the load on the utility grid and better serve the local population. So balancing supply demand, we already discussed this topic. This is energy storage, which acts as a buffer. Storage is always a buffer, and as I said earlier, the peaks are different. For example, the wind generating after night 11 o'clock, the peak demand is over, the energy consumption is less. So whatever energy is generated at that time can be stored in batteries, and it can be supplied next day morning to the peak hours. Same with solar, any generation which is happening after the morning peak, we can store those energies in batteries, and then we can supply it to the evening peak hours. So storage technologies. So this is a very, very important topic. There are multiple storage technologies available, and as I said, your contribution, your research is very much required in this because we need to advance the target. Though India is saying by 2070 we will become a net zero country. If we all join hands, industry, academics can join hands, we can really enhance it with the indigenous technology and a lot of research going into the area. I think personally, I feel that is the best gift we can leave to the next generations. We can leave a much cleaner planet. Because the projections are already saying that by after 2030, the emission peaks are going to come down. And if we can still advance it, if we can do some contribution, it is not only going to benefit our country, it's also going to benefit the entire human race. Not only the human race, the planet as well. So this is a very, very important thing. Storage and conservation of energy is a very, very, very critical and much needed. So when we talk about energy storage, so these are the broadly, I've classified broadly the storage technologies which is available. We have chemical based storage systems like batteries, hydrogen, synthetic fuels, then thermochemical storage systems. Then we have mechanical flywheels, compressed air energy storage, supercapacitors, elastic energy. Gravity-based, we have pumped hydro, gravity batteries, and rail storage. Thermal, we have molten salt, then phase change materials, cryogenic, geothermal, biological, biobatteries, microbial fuel cells. other emerging technologies like superconducting magnetic energy storage, ocean-based hybrid solutions. So lot of storage systems are there, and each has its own advantages and disadvantages. I will just touch upon a few technologies. A lot of literature is available on all the storage system which I have shown in the earlier slide. And the biggest advantage what we have today is most of them, right? Still, we have not seen any practical application in the Indian context. Even lithium ion, the world has installed so many gigawatts of lithium ion storage, which is today the most dominant storage solution next to the pumped hydro. But still, India, we have just started now, and I think very few, right? I think maybe less than 25 gigawatts, if I remember right, of storage, lithium storage facility is only available in India. So battery storage technologies, lithium ion, as I said, it is a dominant storage system. It accounts for about 90% of the global storage installations, mainly because the advantage we have with lithium is the high energy density, fast charging capabilities, and declining cost. So the cost trend I've given in the bottom, the cost of lithium batteries have dropped 85% in the past decade. And by 2030, they are saying that per kilowatt hour, it will be 80 US dollars. Which is more affordable, and more and more storage systems can happen. India is also promoting storage in a big way. If you actually follow the newses, renewable energy news, government has already said any renewable energy project, whether it is going to be wind or solar, it has to have a mandatory storage component in that. So government is also encouraging batteries storage technologies in a big way, and this storage, this is new to us. Let us admit that. Okay, theoretically we might have knowledge, but we have not seen the practical applications. So there is a lot of scope for people like you in the academics to contribute in this field. And then we have sodium ion batteries, potential alternative to the lithium ion. The problem with lithium is the mining of lithium. It causes a lot of environmental concern. Its sodium ion is best alternative to that, because sodium is abundantly available in this world. Benefits is lower cost, safer, non-inflammable, better performance in cold weather. It has a lower energy density and slower commercialization. Lithium, the main drawback with lithium, what I have seen is when we do projects, we conceive lithium, we discuss more on the lithium storage technologies. The biggest challenge what we have today is the power plants what we supply, either it's a wind or solar, it's for life. Its life cycle is about 25 years. And at the end of the 25th year, there is an opportunity to repower or revamp the entire power plant. But if you take today the lithium batteries, their life, it depends on purely depends on the charging cycle. They say it's about the life is about 6,000 charges, 7,000 charges, which will translate to roughly about 8 to 10 years. So it means that in a mid-cycle, right, in a plant's life cycle, you have to replace once all the lithium batteries which you are using for the storage space. Solid state batteries, this is also picking up. The only difference is it uses solid electrolyte instead of a liquid one, and it is fast catching up in EVs because you can considerably reduce the charging time. But the manufacturing cost is still high. But companies, big companies like Toyota, Quantum Space, Samsung are doing a lot of R&D in this space, and they're saying future is going to be solid state batteries. So this is the concern I broadly touched upon earlier also, the lithium and cobalt mining. Environmental damage and ethical sourcing issues are there. Battery waste, less than 5% of the lithium batteries are currently recycled. Again, this is a big opportunity, right? Because if we can find ways to actually recycle the batteries, see, in another 5, 10 years, the scale and volume of batteries which we are going to use in India is going to be multifold, right? I think the storage alone will be about 75 to 100 gigawatts in next 5 to 10 years. This throws a lot of opportunities for us to find ways how we can actually recycle the batteries, also enhance the life of the lithium batteries. So these are the opportunities which are available in this space. And then we have the long duration batteries, vanadium and iron air batteries. So this again, it's on the using liquid electrolytes. So the biggest advantage is whenever you want to enhance the or enlarge the size of the storage, you have to just provide more space to accommodate more liquid electrolyte, and your battery capacity improves. So again, iron air batteries are also technology which is catching up very fast. The main advantage is with iron air batteries is the low cost material, and the storage duration is longer compared to the other ones. Hydrogen is a buzzword. Uh, so everywhere we hear now about hydrogen. Um so India has also announced, the government has also announced a lot of investments in the hydrogen sector. So hydrogen, definitely it's going to be a game changer, and a lot of companies even now started investing on hydrogen. Hydrogen as an energy carrier. Actually, with hydrogen, we can even export renewable energy. Right, it is like for example, India, the renewable energy cost is very low compared to the other parts of the world. So you use the renewable energy, convert water into hydrogen, then you can properly store, and then you can ship to the other countries where the hydrogen can go there, and then they can convert into the any other energy form they need. Right, today there are a lot of research going on. The engines are going to operate in ammonia. So again, from hydrogen, either we can convert to hydrogen or ammonia. Ammonia is much safer and easy to handle compared to hydrogen. So engines are going to operate in ammonia. A lot of research, leading engine companies are doing that. IC engine companies are doing that, and even the gas turbines already proto gas turbine is running on ammonia. So hydrogen is going to present an opportunity where the renewable energy is actually going to get exported. So that is the biggest advantage I see in the hydrogen energy space. Also, there are many benefits for hydrogen. It can be produced from water or biomass. Water is abundantly available, and people are working. It's possible to convert or produce hydrogen from seawater as well. But a lot of research in this area is going how to optimize the cost of producing hydrogen from seawater. That is also presents a very huge opportunity for research, and it's a high density. That is the main advantage of hydrogen. So hydrogen contains more energy per unit mass than fossil fuels. So when people are talking about hydrogen cars which are fueled by hydrogen, one time if you fill the tank, I think you can go up to 600, 700 kilometers. So that is the amount of energy which is available in the hydrogen. So this is also another area which is really popping up in the future. This is also going to be a big game changer. Next is power to X. What is power to X? Power to X refers to technologies that convert surplus renewable energy into other usable forms of energy or products, such as hydrogen, synthetic fuels, or chemicals. The biggest advantage of power to X is it enables a long term energy storage. So as I said, you can produce hydrogen and take it to the another country, store there, and you can use whenever you want. So if you want to have a long-term energy storage solution, hydrogen is going to be the one of the best solution for that. And power to X is basically using the excess energy power, excess renewable power to produce fuels like hydrogen, ammonia, synthetic methane, or synthetic gases. So this is going to be power to X is going to be a boon for carbonizing industries like steel, cement, or other things in the chemical sector. And hydrogen is also considered as a fuel, right, for aviation and shipping. That research is also in progress now. So this coming to the mechanical storage, these are some of the concept. These are very simple concept. Gravity-based storage systems are very simple concept, which I think we can easily indigenize. These are I won't say these are very capex intensive. At the same time, we'll have a better control on storage, and the storage cost will also be less using the gravity-based energy storage. This is something I leave it to you people in the academics to pursue. Pumped hydro storage, it's a proven the most ancient method of storing energy. 96% of all energy storage is pumped storage unit. And when we talk about pump storage, I always have uh, a thinking in my mind, right? Why can't we use seawater? Because our country is surrounded by sea in three sides. There are abundant seawater available. Can we use seawater and do a pump hydro storage? So I was just checking the net, and I found one. Japan, they are already having one pumped hydro storage unit, which basically operates on seawater. So this is also a very interesting area. I leave it to you people to explore this area, because this will, if we are able to produce energy, pump storage energy from the seawater, I think the entire demand of our country can be met only by using this. So this is my personal opinion. Then we have thermal and mechanical storage. I'm not going into detail into each and every storage system, because a lot of literature are available. I'm just giving you an overview, an outlook, so that whichever interests you, you can do a further reading. Molten salt storage in the concentrated solar plants. Basically, it is using using reflectors, solar reflectors, and transferring energy to a salt which is in the molten state, and store the energy in the molten salt, and whenever it's required, it is converted into steam, and then a turbine is operated to generate power. Likewise, compressed air storage is the same concept. You use excess energy to compress the air and store it, and whenever energy is required, you release the compressed air and operate a turbine and then produce energy. Flywheel storage, again, it's a similar concept. Mechanical storage, it uses rotating disks to store kinetic energy.
Yes, audible, sir.
Yes, sir. Yes, sir. Audible.
Sorry, there was some disturbance. Okay.
Yeah.
So flywheel energy storage is again a mechanical type of storage, which uses a rotating disk to store kinetic energy, allowing ultra fast energy release. See, the advantage is high efficiency and quick response time and long lifespan, but the storage duration is very less. So this practically this is used for frequency regulation and stabilizing the power grids. We have seen a lot of flywheel energy storage systems in the world. The storage duration is short, but it is response is very fast. That is the advantage. So as I said before, each and every storage has its own advantage and disadvantage, and it all depends on the application and why we need to store energy and for what purpose we are storing energy. According that, we can actually choose the right storage systems. So this is on the smart grids. We have already talked about microgrids and use of smart grids. And vehicle to grid concept is also something which is picking up. Japan is already there. It's actually reverse. People charge EVs from the grid, and whenever the grid needs the power is exported back from the battery to the grid to stabilize. So this concept is also one of the good technologies which is coming up. So this is just to comparison, just to give you an idea on the efficiency levels. As I said, the solid state batteries are the future. They have the high efficiency levels. So that is going to pick up. Then we have the lithium next to that. Then the flywheel storage, then gravity-based storage, and all this. So this is the efficiency, and the lowest being the hydrogen storage. I think the hydrogen storage efficiency will be somewhere about 50 to 60%. Sorry, 50% if I remember. And compressed air storage is about 55%. So there are various storages and the efficiency. This is the storage duration. This is the that's what I said, right? We actually cannot decide based on one parameter. We need different type of storage applications because the purpose of we storing energy is different for different purposes. So we need to have an overall knowledge of different storage system, and we have to actually pick which storage system suits better for which application. As I said, the storage duration is very less for flywheel, and if you actually see the hydrogen storage is very long. The storage duration can last up to 100 hours in hydrogen storage. That is because you're able to store hydrogen in a liquid form for a longer time, comparatively longer time. But other things, if you actually see, these are all less than 10 hours. Right, compressed air storage is little better. It can go up to 50 hours, but lithium and all other things, we have a limitations of storing only about less than 10 hours time. And the cost trends now, hydrogen is very high at the moment because still the green energy, using green energy to produce hydrogen, that is the green hydrogen, it's catching up now. And most as we go forward, mean another 3-4 years, the hydrogen storage cost can come down, but still a lot of infrastructure is required for transportation and storing hydrogen. So that is the main cost driver for hydrogen storage. But otherwise, if you actually see, the cheapest is compressed air storage, gravity-based storage. So you have the different cost levels to actually find out which storage suits your budget. And this is the global picture, right? Global deployment of various battery technologies. So lithium ion, as I said, 80% or 90% of the storage what we have today in battery energy storage system is lithium ion. And then we also have pump storage. So other than that, all other technologies are just catching up. And most of the technologies are also new to India. So that's why I said that there are a lot of opportunities in this field. There are a lot of opportunities in this field to explore. And regional adaptation. This gives you an idea how the technologies are being adapted. India is an area of interest. If you actually see India, it's going to be 50% at least is going to come from the lithium ion batteries. And then we have pump hydro storage. And then we have the hydrogen storage and the flow batteries. So that's how the outlook look for the India. And it's almost comparable with the rest of the world. Future growth projections for energy storage technologies. So lithium is going to grow, hydrogen is going to grow, pump storage is almost flat, and the flow batteries is also going to grow. So from 2025 to 2040, this is how the growth looks. So potentially the lithium ion batteries, pumped hydro storage, the flow batteries are the potential areas for research in academics. And the storage market projections in US billion dollars. So it's like same actually in terms of $1 billion. If you actually see, the hydrogen is picking up, right? It is actually coming very close to the lithium ion market. So hydrogen storage market is going to be a big player, and the flow batteries has also have considerable investments, and the pump storage it's about 250 billion, well, slightly close to that. And this lithium and the pump storage, sorry, the lithium and the hydrogen storage is between about 700 to 900 billion dollars. So this is about storage. Now we will quickly touch upon the energy conservation strategies and policies. These are all very common sense questions. Why it matters? Yes, either we have to generate more or we have to conserve energy and use it efficiently. So every unit of energy saved is equal to a unit of energy produced. So being efficient in our consumption adds a lot of value. So industries and buildings consume about 40% of the global energy. So there is a big opportunity to actually look into this energy audit, energy conservation strategies, and energy efficiency measures directly reduce the electric bill. These benefits are tangible. And smart energy management system, there are a lot of IoT based things are already there in the market. AI based data analytics, which will actually give you the real time data and helps you to manage your energy better. As I touched upon AI and IoT energy conservation space. So this is also a very fast area which is coming up. There are a lot of AI models which is already there, and a lot of energy management system based on monitoring and analyzing the real-time data. Demand response and smart grid technology is also picking up now, and as more and more small and micro grids are coming, there is a big opportunity in this area. How we actually respond to the demand which arises, either we manage the demand or lower the demand, or integrate many sources of energy to meet the demand. So this is also a very important factor. The role of demand side management, you can a lot of literature is available, you can go through it. Then this is also a concept in the energy conservation phase, a time of use pricing models. There is many grids you have today, even in India. If you actually see, there is peak pricing for the electricity and off-peak pricing. So most of the grids in the world, they discourage consumers using energy in the high peak, except the normal domestic customers. In some countries, actually, they give you an incentive, right, if you are lowering your consumption during the peak hour. So policy matters. We already touched upon the subject. A lot of companies and governments have come with net zero policies. This is very important because everyone, government, private industries, academics, individuals, everyone has to work together to achieve this net zero targets. So policy is very important, and different companies have different policies. India's PAT scheme, perform, achieve, and trade schemes have really helped. The impact, it's 12 million tons of CO2 reduction annually is estimated through these PAT scheme. And EU has an energy efficiency directive. It requires member countries to improve the energy efficiency by 32.5% by 2030. So it's a directive from the EU to the different European Union countries. And China's energy saving law mandates industries to audit and improve energy efficiency with strict consumption limits. So government is also putting a lot of efforts and enforcing a lot of rules to monitor this. And this policy support is also a very important factor. And the impact of energy conservation in various sectors. So industrial is the most energy savings can go up to 30% there. Commercial buildings about 25%. Residential we can save about 20%. That is the scope which is available. And at last, the transportation is about 15%. And this is the effectiveness of the various policies which has been initiated by the government, right? Japan's there is a ZEP policy which has produced an energy reduction of 17%. So India, if you actually see the PAT scheme, it has come up close to about 12% energy reduction. So there are many measures the policy is given, and the policy, this shows that the policy government doesn't stop with implementing the policy. It also takes pain to see the implementation and benefits which are rising out of those policies. And demand side policy savings, various countries, India is also there, about 25 to 30, 25 gigawatts of energy reduction using demand side management. And USA is at the top with 50 gigawatts energy reduction. Smart grid efficiency improvements. Again, in the percentage, grid reliability improvement, somewhere between all countries have achieved somewhere between 20 to 40% grid reliability improvement. So this is the on the smart grid. And government, as I said, a lot of push is there for renewable energy incentives, and how this has impacted the increase in renewable energy capacity. So if you actually see China, Germany, India, it has all these incentives which was given by the government has helped increasing the renewable energy installation across the country. So the last few slides, the key trends. So as I said, the global energy market for storage is expected to reach 1.2 trillion by 2040. So this is a big space, and battery storage or any storage technology is going to have a big opportunity and big market moving forward. So this is one of the big good areas to focus. And the innovation in energy storage technologies, various storage technologies, which will definitely help. Any small innovation in energy saving is going to help. Then the another big advantage is there's going to be a consistent support from the government, irrespective of the country, because the world is moving towards 100% renewable energy. So the government is not going to stop supporting; it's going to continuously support the players, and it presents a good opportunity for every one of us. So career opportunities. Right now, I'll finish my presentation with two slides. One is on the career opportunity, and other is on the research. So career opportunity. These are the various roles. So India, we are saying 500 gigawatts of renewable energy by 2030. I'm in the sector. Today, we face acute shortage of skilled manpower for renewable energy. Okay, and the people at the field, right? We need more and more youngsters in the field, because it's not an easy job like any other, right? Either it's a solar plant or a wind plant. So wind is always working at heights. Solar, it's very extensive. It's a wide area. Every day you have to be in the field. You have to be in the sun. Likewise, offshore energy is just catching up in India. It's coming to India. Maybe it will take another 4 or 5 years. So that is also going to open. So we need a lot of youngsters, and there is a lot of job opportunities available. And if you can train people in the college, right, when they do the courses, any technical courses they're doing, if you can train them, at least impart them the basic knowledge of renewable energy, that is going to open a lot of job opportunities for people. Energy storage. So just to give you an idea, right, 500 gigawatt. So India, the wind potential alone in India is about 1,000 gigawatt. Sorry. It's about close to about 700 gigawatts, and we have only installed 45 gigawatts. Likewise, the solar capacity is about 1,000 gigawatts, and we have only done 100 gigawatts. So it means that we have captured only 10% of the available solar capacity in India, and roughly about 10 to 12% of the wind capacity which is available in India. And further researches are going on, and definitely the technology will emerge, and they will keep designing new turbines which can operate in very, very low wind zones. So the opportunity is endless, and the renewable sector is going to be the sunrise. It's already a sunrise sector. At least another 30-40 years, renewable energy is going to be a very, very lucrative and sunrising. It continues to, it is going to rise continuously. And what are the key job roles? Energy storage engineer, because as I already said, a lot of storage opportunities are going to come. The grid integration specialist, battery recycling and sustainability expert, hydrogen energy specialist, artificial intelligence and Internet of Things energy analyst, renewable energy policy consultant. So a lot of microgrids are going to come, and every industry is going to have its own source of power, that too renewable power. So a lot of these skills are will be required moving forward. And these are the research opportunities which are available. The next generation batteries, I already said, the solid state battery is going to be the future, and the various opportunities like sodium ion, lithium sulfur. So a lot of opportunities are there, and then long duration storage batteries, AI and digital energy management, because you need a proper energy management, because you're going to integrate different sources of renewable energy like solar, wind to a battery component, storage component. So it needs extensive understanding of wind, solar, and also the storage system. So that is also going to be a very, very good opportunity, and sustainable energy conservation strategies. So again, the global investment trends, I will not touch into this. I'll not get into this in a brief, because a lot of slides we have already seen in that. So this is the conclusion. The storage industry will be the key enabler of the global sustainability goals. So the world is moving towards 100% green energy. And if the world wants to achieve this target, it is not at all possible without energy storage and conservation. So that is the opportunity, size of opportunity which is available. A massive career and research opportunities exist along engineering, artificial intelligence, policy, and finance. Government and corporations are making a large-scale investment in solar innovations and conservation strategy. So that also presents an opportunity. Those who specialize in energy storage, smart grids, and conservation technologies will be highly sought after in coming decade. I won't even say coming decade, coming next 2-3 decades. So this is the market projection. What is going to be the market size for global energy storage? It's about 200 billion US dollars. So that is the market size. And then the projected job demand growth in energy sector, right? It is going to be about 25 million jobs in the energy sector alone. India, I think it's going to be at least 2 or 2.5 million jobs in the coming next 5 to 10 years. And regional investment trends in energy storage. So if you see all the countries around the world, they are going to invest in storage. So India is also going to enlarge. So your research in storage or your expertise in storage will find you more and more opportunities around the globe. And that is the this available. And with this, I in my presentation, I'll be happy to take some questions. Thank you.
Thank you, sir.
Participants, any questions? From my side, one question, sir.
Yeah.
Actually, energy audit is one of the tool to reduce, to get energy conservation.
Yeah.
So our government is strictly following that energy audit process, sir, in all industries, sir.
Yes, government is strictly following. And
because there is a separate body is there, Bureau of Energy Efficiency.
Correct.
Yes, sir.
See, that is one. See, government implementation is one side, right? At least the public sector units and other things, government has already made mandatory for the energy audit and other things. But I'm seeing a lot of private parties interested in doing improvements. Right, the industries I go, because the power cost is skyrocketing, and every unit they save, they are saving money. And if you can actually do a good energy audit and provide solution, there are a lot of people to take it. There is a lot of opportunities available in the market.
Yes. Thank you, sir. Thank you, sir. So, any other questions? Participants, otherwise you can put your question in the chat box. I will read it.
Good afternoon, sir. I think This is a very nice presentations. Yeah, almost all the energy is converted. We are storing in our minds, the battery storage, mechanical storages, everything. So last 1 hour or 1.5 hours, we have stored all the energies. So all the form of energies. So now I think this hydrogen is the. I think what we are understand from the presentation is hydrogen is the future storage energy, right? I think
Yes,
cost
I
effect.
think yes.
No, not cost wise. Cost wise, a little bit higher only. Okay. I think that's why we understand. So almost we are listened and taken the notes also. So we are stored in mind also partially because the lot of information is given, sir. So very good presentation as part of our organizer, Dr. Purushothaman. So I think this is a wonderful the presentation we are observed here, and maybe it's useful for all the participant and doing the research and looking the job in this energy auditing, energy conservation. Thank you very much, sir.
Thank you, sir.
Thank you.
Thank you. Nice
So
of you.
participants, sorry, coordinator Sinnapandian sir, can I have
Yes.
one question if
Yeah,
time
definitely,
permits?
sir. Definitely, sir. You can ask, sir.
Sir, good evening, sir. Dr. Rajendran, sir. I am Ishwaramurthy. So sitting in this Jammu and Kashmir and listening your lectures. It's very interesting. So you given the talk related to the global perspective of the energy conservation. It is an informative. So my question is connected to what you call that the government is introduced the green hydrogen missions. How that industry is preparing for that. So how that job potential or research potential which is coming to the participants, probably 143 participants, probably 10% of them might be interested on this green hydrogen missions. So probably the government also spending 2 lakh crores money. That's what I seen that. So how that industry is keeping it ready for this accomplishment of the missions. Would you
Yes.
highlight this?
Yes, sir. So, lot of private companies are constructing hydrogen plants. A lot of companies have already started manufacturing electrolysis. So that is going to be a big market, and the way forward, India will be one of the largest hydrogen hubs in the world. So the what I've seen the trend now, what I'm seeing is a lot of renewable energy plants and hydrogen units are coming in the places which is near to the port. So the main objective is going to be exporting hydrogen out of India. So that's a bright market, and infrastructure. Government is also going to invest in infrastructure because storing and handling hydrogen is not very easy. If we want to really cut down the cost, the point of consumption of hydrogen should be very close to the point of production. So some big industries are planning to have their own hydrogen, and then they want to use it as a fuel. This is shaping up, sir. We are also very keen on watching the development. I think in another 2-3 years we will have a clarity. Maybe end of the next year we can see a lot of hydrogen plants start producing green hydrogen, 100% using renewable energy.
Thank you, sir. Thanks for your insight on my small questions. Thank you so much.
Thank you, sir. Thank you very much.
Any other questions from participants?
Sir, very good afternoon. Myself, Vishwadeepak from Bharat University.
Yes, sir.
So, very nice to hear you, sir. You have been explaining all the parts very nicely. But one of my concern it is that many of the places you have been highlighted about the private body of doing all type of the energy conservations and generating and operating throughout the world.
Yeah.
So what I am trying to be understand that may the government, if they take the initiations to put a plant and do this particular task, might be it will be quite more grateful for the ordinary peoples who will be there. And that also in the terms of lithium, now all the energy, battery energy, it is most of the things it is working on the lithium only.
Yeah.
So how we can take the entire climate of the lithium to the green one, That is the one thing. If you will clue me somewhere, it will quite connect it for me, because I understand the entire slides and you have been presented in a very nice way. Many pictures, many graph you have been imported over there. So
Yeah.
it was having a little clear picture to me, but this is quite confusing for me. How this entire concept, the market will change to this green one. That is the one concern. If you will explain, I will really
Yeah.
grateful.
Sir, actually now India primarily today there are two types of storages. One is on the pumped hydro storage. So pump hydro storage, there are certain limitations because the pump hydro storage, you need to build a dam. You need a consistent supply of water. It should be close to a river. All this, but is one of the cheapest. And once you build a pump hydro system, it will last for 50, 60 years. So one side, there are a lot of things happening in the pump storage space. And battery, as I said, unlike other countries, we are just picking up now. And today, if you actually see the world, it is dominated by lithium-ion batteries. Definitely, an alternative is required because there are a lot of advantages using lithium-ion batteries in terms of cost, in terms of charging, and in terms of discharge. That is the reason I listed all the storage available. And see, government is willing to support. Only thing is we have to show the government. Yes, see now the government is asking us to store energy mainly for two things. One, they are talking about RTC. RTC is round the clock renewable power.
Yeah.
So government is tenders are coming saying that you please make arrangements to supply round the clock renewable power. That is one requirement. And the second requirement is firm dispatchable renewable power. They are saying morning 4 hours, evening 4 hours. You give a commitment to dispatch, firm commitment to dispatch renewable powers. So these are the two things, right? As you said, the hydro pump storage cannot be installed in all the places. There are a lot of restrictions in building a pump storage. So the easiest and the proven technology available now for commercialization is lithium ion. So that is the reason most of the installations are happening with lithium ion. But as I said, there are a lot of research going on. Soon, solid state batteries technology will emerge. And as we focus more and more on microgrids, we can even look for an off-grid storage system where we can try all the different models which we discuss. So it depends on the application and the use case.
Yeah.
There are some questions from chat box, sir.
Yes, sir.
Dr. Samuel Raj, green hydrogen mission will be have a market solar to hydrogen. Green hydrogen mission will be have market solar to hydrogen. This is the question, sir.
Yes. See, what is green hydrogen? Hydrogen. Producing hydrogen is not a new technology, right? This has been happening for many years. Maybe I don't know, maybe 100 years before. I don't know. So as such, producing hydrogen is not a great technology. It's already there. What is the difference? The difference is using green power to produce hydrogen. That is green hydrogen. That's all. So whatever energy you're producing from solar is a green energy, and that if you use that energy to produce hydrogen, it is called green hydrogen.
Yes. Another question, sir. Mr. Arul, yes. Use of ammonia in IC engines. Any current projects going in India?
India, I'm not sure, but the company which I worked earlier, Wärtsilä Corporation, they are already running one prototype. That's what I understand.
Yes, sir. Yes. So another question, sir. How can a UG graduate can specialize in energy storage, smart grid to become energy storage engineer? From Anjana Devi.
See, a lot of online courses on storage is available. First and foremost is, as I said, the concept is picking up, right? We need people who at least understand the technology And then the market is opening up now as more and more tenders are going to come. As I said already, government has mandated that any renewable project in the company should have a storage component in it. And first we need to qualify ourselves academically, then get into a job, see one installation of batteries, storage system, any storage system, then gain experience. Then you can take bigger roles in energy storage, because the market is going to grow, and as the market grows, we need a lot of people with energy experience.
Yes, sir. Yes, sir. So any other questions for participants?
Sir, Natesh Kumar here.
Yes, sir.
Sir, what are the challenges we're going to face while eliminating DG sets, sir? DG sets, normally when our power cuts, we use DG sets.
Correct.
This storage mechanism, how it will be helpful for the industry, sir?
See, now you asked a very valid question. I think some parts of Maharashtra, they already issued a ban on using DG sets. And even the Tamil Nadu government, right? If you are constructing apartment complex, it's mandatory to have a solar installation in that. So world is moving now. If you ask me immediately, can we replace the DG set and do? It's going to be difficult. But the storage concepts are evolving, right? Like having a solar rooftop solar, and then connected to the battery. Use solar power to charge your batteries, and whenever there is a power failure, you can use the battery power to power. So that is the normal storage system which is coming up now. So that is one. Second is there are also options available where you can actually purchase the green power. So that policy government is discussing. Say, for example, you have an office, but you don't have a space. I have a open ground nearby where I can install a small microgrid. I can use solar, wind. I can generate energy. I can store. And whenever there is a requirement for you, I can supply from there. So that side type of policy is under discussion. I don't know how fast those policies will come. Once those comes, yes, definitely. But very soon, I think the DGs, all the generators, diesel generators will require replacement, and we have to have big size storage batteries. Normally, these storage batteries, instead of charging from the renewable energy sources, you can charge from the grid power. And whenever there is a power outage, you can use those battery current to operate.
Any other questions from participants? Okay, if there is no questions. So, sir, really, when I was approached regarding resource persons through Mr. Pundurang, he was my classmate.
Oh,
so, I gave some really more than 10 topic. But you chosen this topic. Really, you stick to this topic, because it's very difficult to collect all those data globally. But you given very nicely to this topic. Very stick to this topic. Global energy is very, everyone enjoyed this topic, sir. Mr. Jabamani?
Yes, sir. Yes, sir. Yes, sir.
Yeah, please. What are thanks?
Okay, sir. Okay. Once again, a very good evening to one and all present for this beautiful occasion. I would like to thank our guest speaker, Mr. P. Rajendran, Chief Associate Officer, Ever Renew Energy Private Limited, Chennai, on behalf of our SPCET fraternity. Thank you, sir, for elaborating us more about the storage. We learned about new things regarding the storages, especially that hydrogen storage and all. Thank you, sir. Thank you once again, on behalf of our management and our organizing team. Thank you, sir.
Thank you, sir. Thank you. It's my pleasure.
Thank you, sir. So
Thank you.
participants can unmute your video, sir.